Okay, hello. Welcome to Data Science with Julia. It's been a long while since I made a video. Yeah, that's because like I was researching about like SVM, that is like support vector machines, and I couldn't get it properly, and so like I was just thinking about it and all those stuff. And next, I was looking into Clojure, a programming language called Clojure, so that we can offer some better, what to say, very stable software to our clients. So that's what was going in data making. So I couldn't concentrate much on what to say, putting videos and then updating my book, like data science book, right? So that's the thing. Okay. So, but yeah, like now I'm just kind of found some free time and all the stuff, so I can do it. So today we are just going to go into a thing called hot and cold learning. So what is hot and cold learning? So like if you know, like okay, like you have this thing called knob, okay, KNOB. Okay, so I think you would have seen images of it, or what to say, like okay, wait, let me put like temperature knob. Okay, yeah, so this is some kind of a temperature knob or something like that. Okay, this indicates this indicates the amount of temperature that needs to be set. So you can, okay, let's say like you are before a heater or something like that, and I don't know. This is okay. I don't know what temperature this is. It goes till 570. Okay, so okay, like let's say you are having some furnace or something like that. You want to smelt something or something like that. So you put some unknown metal and you want to find its melting point. And so what you do is like first it's zero, then slowly you raise the dial to become 120, and slowly slow, and you just find somewhere around about around 300 it melts or something like that. So sometimes, if you raise it too fast, you might even need to dial it back in order to find a melting point, or a point where it really freezes, melts somewhat in a meta state. Okay, so that is exactly like hot and cold learning. Just like you manipulate this knob and find the melting point of a metal or something like that, you also manipulate weights or whatever, the parameters in hot and cold learning, so that you find the optimum parameters. Let me tell you how. So I think I read this thing in Grokkin neural networks. It's Grokkin neural network. Okay, so Grokking. Okay, I think it's Grokking deep learning, right? So this is the thing. For some reason, Manning Publishing books are quite good. Okay, so I don't know how they do it, but their publishing quality is quite good. So I recommend that. Of course, nobody's sponsoring these videos and all those stuff, but yeah, like this is the thing, right? Okay. YouTube has become so corrupt. Even if we want to recommend something, we need to say, okay, look, this is not being sponsored. Okay, so okay, right. Okay, let's look at very simple example. In this book, like you would have seen like guessing a number. Why I tell guessing a number is it's very easy, right? So you need to learn the core concept in the easiest way, and then you can just think about it. Okay, so and mostly in this book we'll just finish by fitting a what to say line to set of points. Okay, that's it. There is a lot of things in actually real machine learning. You need to split the test train data, blah blah blah, and all those things. There are terms like true, positive, false, negatives, blah blah blah, and all those stuff. I don't want to bring that into this book, because like this is introduction to data science. My book is about introduction to data science, and so this is all about understanding rather than becoming a professional. Of course, a solid understanding is needed for solid profession. So this is first all about understanding. I don't guarantee this reading this book alone will make you professional, unless you're really smart. Okay, so that's the thing. Okay, so yeah, enough of marketing about my book. Okay, so but of course I am earning money from the book. So yeah, I'm sponsored by the book, right? So yeah, let's go into our subject. So the intuition, right? So first we have this number 42, right? We want to guess this number. So what we do is like we just pick any number from 0 to 100, and we just put it as guess. So it's 87. So now we have a step parameter and we name it as alpha. That we have it like 0.1. Oh, here 0.1 is good enough. Okay, so like because I just know from my experience or something like that. But sometimes if you have large alphas, your learning will just go ori, and that's it. Your system will never learn. Okay, so now we do the error. The error is nothing but the absolute value of number minus guess. So we are not worrying about the sign or something like that, like gradient descent or something like that. Okay. So we make two guesses from this guess. So imagine the guess splits into two. One is the guess plus alpha. That is like 42. Okay, sorry, 87.1. So the guess plus alpha. And another one is the guess minus alpha, 86.9, right? And for this hot guess, we find a thing called hot error. So this is nothing but the very same thing, the error, very same thing, but the number minus hot guess. Okay, and we take the absolute value, and we find that it's slightly greater than this error. Okay, and for cold error is nothing but the number minus cold guess, that's the absolute value, and we find that it's slightly less than this error. So what should be a new updated guess? So since the cold error is lesser, right, than our original error, our guess should be cold guess, and you just do it again and again and again and again till the guess almost becomes number. Okay, so that is the thing. So that's what we are just doing over here. So for 1 to 1000 times, okay, so what we are just doing is we are having the error. We are computing the hot guess, hot error, cold guess, cold error. If we find that hot error is less than error, then the guess is hot guess. And if we find cold error is less than error, then the guess is cold guess. Let me just make this a little bit bigger in case. And I found some tricks. I've been using Jupyter kernel for so long, and I have never hidden the sidebar. Like only like I'm just doing it only for few days. So that's the thing. I don't know why this plots. It just faded away, right? Oh God, I had a very beautiful plot. Let me see whether it works. No, doesn't seem to work. Let me do run all cells. Oops, something happened. Okay, right. Okay, right. Something wrong happened. I need to fix it. View. I was happy that I hit this left sidebar. Okay. Shut down kernel. Come on. Right. Let us save it. Okay, now let me start it again, right? Now kernel, okay, so run, I don't know, like I used to do this thing, like restart kernel and run all cells, but that seems not to work recently. I really don't know what happened, right? Is the kernel restarting? Yeah. Uh, no. Oh God, I'm sorry to waste you people's time, but something just happened, right? Shut down kernel. Maybe if you want, like, okay, you can skip this, but if you want to know how I'm debugging, possibly you can see this. That might help you. So what I'm just doing is it doesn't start properly. So I'm just doing this thing. And what I just do is like, okay, like I just run all sets. Yeah, now it's running, right? For some reason, this restart kernel and run all sets doesn't seem to work recently. I don't know why. Like, I need to update something. I'm not sure. So it's just okay, yeah. So I'm just doing it like hundreds of times, and now the guess becomes 42 or something like that. Now, yeah, you just see like the guess is 29, and what to say. Now we need to what to say, the guess should be now the hot guess because the hot error is less. Okay, so that's the thing. So, but yeah, anyway, like whatever it guessed, it comes to near to 42, right? And okay, I think we have a very sad situation over here. So the guess is somehow 5 this time, and it just showed a plot like this. Okay, let me just run it once again, right? So okay, so I have a number 5, right? And I'm just putting guess something, and I'm collecting all the guesses in this array, and I'm just finally plotting this one. So this line shows us the number to guess, and this shows the guess. Okay, so I'm just run it once again. So I ran it again. Now let me plot it. Okay, so actually, yeah, I just screwed up the first time, so that's why you just see the red line. But actually, yeah, the number is actually at 5. Okay, and this is the guess. I think it started somewhere around about 7, and it just reduced and it just came and joined the number. So that's the thing, right? So let me just stop this. Okay, let me just save this, right? Okay, fine. And let me what to say, show you how I did it with a line. Okay, so now this is for a line. So we have a line 2x plus 5. Okay, over here we just have a 2x plus 5. And what I'm just doing, like I'm just taking x is equal to 1 to 5, and I'm just getting the values of y, and I'm just putting it like, I'm just gathering the input data. So I'm just having the input data x and y, and I'm just plotting it. Okay, so these are the data inputs we are going to give to our hot and cold algorithm. That is like 1 comma 7, 2 comma 9, 3 comma 11, and so on and so on. So that's the thing we have just plotted. And note that Julia plots doesn't start always with 0 comma 0. Okay, so it starts somewhere around 7 and something like that over here, like in the y-axis. The x-axis also, it's not 0, it's starting somewhere else. Okay, so that's the thing. And we write a error function. So we have this total error. So the inputs and outputs will be the x and y, the capital X and capital Y, computed capital Y. Okay, so this is the data we are just generating for ourselves. We don't want to take data from external thing and do it. But it doesn't mean that in this course I always take external data. I always don't take external data. For some and all, like for decision trees and all, I'm taking external data, right? So it all depends on the situation. Whichever is easier, I'll just do it, okay? So what I'm just doing is like I'm just having an error function. So this is to find something about a line, right? So line equation is mx plus c. So I just get mc, the inputs and outputs. So now I need to see whether this mc fits this inputs and outputs property. So what I have is like total error, and I just zip this inputs and outputs, and I just take each and every value as x and y over here. So the total error is nothing but I'm just adding it mx plus c minus y. Okay, so that's the thing. So for each value of capital X, I take this as x. If at all x and y are being, the capital X and capital Y are passed as inputs and outputs. For each value, I just take it and I just compute the total error. Then I just do the average error, because like I don't want the entire total error. So we can use the entire total error, but yeah, it's better to take the average. Okay, so that's the thing. So it's actually like 2x plus 5. Let us see like what if I give like 0x plus 0. Okay, so the error is 11. That is the average error is 11. So if you want, yeah, you can just see like sum of y plus length of y. So because that line is 0 comma 0 is nothing but it just lies flat. Okay, so all the errors are nothing but the heights of this line from the x and y axis. And please do remember, this graph doesn't start from 0 comma 0. So don't get confused. Okay, so that's the thing. So if I just give like 1 comma 2, the error reduces from 11 to 6. So I think 1 comma 2 is better fit compared to 0 comma 0, right? Because over there the error is 11, right? So now we just know the errors, how to compute the error. So the basic thing in machine learning is you need to know how to compute the error. So that's the thing you use to tweak something, right? So so finally, yeah, you get like this. So the algorithm slowly fits the line to this point. So let us see, right? So first, now I'm just using everything new over here. So I'm just using plots, and next I'm just having a line 3x plus 5, and I'm just taking some random value of m and x. Alpha is 0.01, because like if I give 0.1, it's not learning properly. I don't know why. So because yeah, if you have this step function, that is the step constant, if at all the step constant is very high, it won't learn. It'll just overshoot, and I think that's what happened, right? So I just made it 0.01, but that means I need to do a lot of steps. But yeah, that's okay, I think. So x, I'm just taking 1 to 5, and I'm just taking the y values. Okay, these will be the training inputs. Okay, so, and I'm just taking the current error, right? So I'm just having this hot m and cold m. So if the current error is greater than error, then m is equal to hot m. So that's what I'm just doing. So if what to say, that's the thing. I shouldn't have put. Okay, so this error, for this error, hot m goes in, and C and XY goes in. Okay, so, and similarly, like okay, I should have what to say, put this error over here out, because it's computing twice, right? It's algorithmically inefficient, but this is a learning book. I don't think algorithmic efficiency comes over here. So let me leave the code like that. Okay, so but maybe if I refactor my book, yeah, I will think about that, right? So similarly, if you do a cold dem, and if the error is less than current error, or the current error is greater than error, m is equal to cold m. So similarly, the same thing. I'm recomputing the current error with the modified m over here. So, and then similarly, I'm just doing the same stuff with C also. So, and we are just plotting it, and I'm just gathering the plot as GIF over here, so that like it will be like an animation. And what I'm just doing is like I'm just only doing like 1 in 5 frames plot, because like this is like 500 frames, right? Uh, it took a lot to plot, that a lot of quite a time to plot, and I'm using M1, like Mac M1. That's one of the powerful laptops available. Like so, it's not like M1 Pro or Max, it's the M1, and but yeah, it is still powerful, right? And what I'm just doing is like only in, but still it took time. So I just thought, okay, and this graph also, like now it's just taking like 10 seconds or something, like just to do one full animation cycle. But at the time it took like 20 seconds or 30 seconds, because there are a lot of images in that clip. So what I'm just doing is like I'm just plotting the scatter plot. So that plots these 5 dots over here, right? And then this line plot, I'm just doing this mx plus c, right? And I'm just plotting this, what to say, I'm just appending this plot to this scatter plot. I'm just appending this x value, that is 1 to 5, and then this line plot coordinates. And since this is plot, this will plot as a line, right? And y limits, I'm just setting it from 0 to 25. So this is the educated guess. Educated, or it's a trial and error guess which I just gave. And x limits, I'm just setting it from 0 to 6, so that like you'll just have this nice padding and all this stuff, right? So that's the thing. Okay, so if you can just see, like, okay, as m and x, what to say, is being guessed out, you can just see the line that's being what to say, kind of fitting. Like let's watch it. I'll give the commentary, right? Come on, reach that. Yeah, look, it's just slowly, yeah, it's just fitting, and it almost got the C right, and M is coming in, and all those stuff, and that's how it is, right? So, and finally it's 2.98 and 5.06. So that's the thing. So hot and cold is learning is nothing but like turning the knobs. Okay, trial and error, or turning the knobs. That is like it's not trial and error, like you measure the error function each and every step. So, and I read the literature saying that, okay, like this is kind of a costly algorithm, because you try for everything and you just see and all those stuff. But what to say, that's how it is, right? So yeah, I hope you understood. So this is one of the most simplest of learning algorithms, but even if you don't find it simple, don't worry. Rewatch this video, go to some other place, try to learn, you will get it ultimately, right? So that's the thing. Or become a member of some forum where AI is being discussed, and you will ultimately get it. So don't worry, right? Okay, thanks for watching my video.